Hello everyone. In this video, we will cover recursive formula. First, consider an n-year term insurance of one issued on an individual at age X. Here we have the death benefit. Only one of this $1 will be paid at the end of the year of death if the individual dies within this n-year period. Separate this into two parts. The first part is the 1-year term insurance. The $1 is paid at this time point if the individual dies before reaching age X plus 1. And then the remaining portion, we can regard this as an n-1 year term insurance issued on age X plus 1. Discount back to age X. We get the recursive formula. This recursive formulas link the relationship between an n-year term insurance on age X with the n-1 term insurance issued on age X plus 1. The recursive formulas also applies to the second moment. With similar argument, we get similar recursive formulas for the whole life insurance, as well as the n-year endowment insurance. Let's take a look at an example. For a standard life at age 50, the mortality probability at age 50 is Q50, which is 0.02. The actuarial present value of a 20-year term insurance of one on age 50 is 0.285. The interest rate is 5%. Another individual just had surgery. The mortality probability at age 50, denoted Q50 with superscript S, is 0.06, but has standard mortality at all other ages. Calculate the actuarial present value of a 20-year term insurance of one for this life at interest rate 0.05. The only difference between the standard life and this individual is the mortality probability at age 50. Q50 versus Q50 with superscript S. And the remaining probabilities are the same. Make use of the recursive formula. For the standard life, we have this big A notation. And for this individual, we have this big A notation, simply adding the superscript S. For the standard life, the recursive formula, we have nu times Q50, and then plus nu times P50, and then the 19-year term insurance on age 51. Similar expression for the second one. Plug in the numbers, and then from the first expression, we can get a 19-year term insurance. The 20-year term insurance, the expected value is 0.285. Nu is 1 over 1 plus I. Q50 is 0.02. And then the second term, we have this. From this, we can solve for the 19-year term insurance on age 51. Substitute into the second expression with Q50 as 0.06. And then we get the answer, 0.3122. Another example. For a whole life insurance of one on 56, death benefit payable at the end of the year of death, we are given the value of P55, the difference of A56 minus A55, 0.012308, and then the difference between the two second movement, as well as nu. Nu is 0.926. Let Z be the present value random variable for this insurance, and we need to get the variance of Z. That is, we need to get the value for A56 and the pre-superscript to A56, the second moment. We use of the recursive formulas for the expectation as well as the second moment. And we are given A55 and A56 and the corresponding second moment. And then we can solve, or we can get the quantities for A56 and the pre-superscript to A56. We get the relationship. This is from information number 2. And then A55 with the recursive formula, this equals U times Q55. Q55 is 1 minus P55. And then the second term, from this, we can solve for A56. Similarly, for the second moment, the expression here from information number 3, together with the recursive formula, we get the second moment. And then the variance is 0.0401. Next, we get back to the N-year endowment insurance. We have already established a set of recursive formulas. And now we are going to establish the second set. Again, split it into 2 parts. The N-1 year term insurance, as well as the N-year period endowment. For this $1, the N-year period endowment, the probability of getting this $1 at this time point is N-1px. As long as the individual survives beyond age x plus N-1, the insurer needs to pay this $1, no matter whether the individual dies or not. The first portion is the N-1 year term insurance on X. Getting the expectation, the N-year endowment insurance. So this equals to the N-1 year term insurance, and then plus the present value for the N-year period endowment. For the second term, factor nu to the power n as nu times nu to the power n-1, and the expression in the bracket is the n-1 period endowment. The second moment, the second term here, we have nu to the power 2n times n-1 px. Factor this as nu squared times nu to the power 2 times n-1, and then times n-1 px. The expression in the bracket is the second moment of the N-year period endowment. And we have this second set of the recursive formulas. All right, let's take a look at an example. For a 11-year endowment insurance of 1 issue on age 30, death benefit payable at the end of the year of death, and we are given 4 quantities. We have the expectation for a 10-year term insurance on age 30 and the corresponding second moment. And we have 10p30 as well as the interest rate. Let Z be the present value random variable for the 11-year endowment insurance. Calculate the variance of Z. We have 2 sets of recursive formulas. The first set, we relate the insurance, the n-year term insurance on HX with the n-1 year term insurance on HX plus 1. And the second set, we relate the n-year endowment insurance on X and the n-1 term insurance on X. What do we need to get? We need to get the 11-year endowment insurance on age 30. The age remains unchanged. The value for X is the same. For the first set of recursive formulas, we have age X versus age X plus 1. And then for the second set, the age remains unchanged. So here we make use of the second set, the recursive formula. Doing the substitution, the 10-year term insurance 0.08 due to the power 11, 1 over 1 plus I, and then 10p30. We get the expected value, 0.5646. And then the second moment. The second moment here for the 10-year term insurance, 0.072. And then the corresponding value for the new and 10p30. We get the second moment. And from this, we get a variance, 0.0085. That's it for today's video. Thank you for watching and see you in the next video.